Hello everybody, and welcome to today's presentation, How to Make Predictive Analytics Your Next Passion Project, brought to you by Logi Analytics. I would like to introduce you to our presenter, Sriram Parthasarathy. Sriram is Chief Product Owner of Logi Predict, a new product in the Logi Analytics platform. He works with customers to embed predictive insights directly into the applications business users use on a daily basis. Sriram has over 20 years of experience in designing enterprise and OEM analytical products.
Good afternoon, everyone. Thank you for joining the call today, taking an hour of your valuable time to spend time with us. So my goal today is to get you some good ideas for how to get started on your predictive journey by utilizing one of your internal or your customer facing use cases, and how do you assemble the data, how do you create a predictive model without spending too much time on writing code. So in that process, for those who may not be familiar with predictive technologies, I have a quick 5 to 10 minutes introduction on that process, and then I'll probably spend around 10 minutes on talking about different use cases you can focus on. We have spoken to more than 300 customers. In that process, we have learned a lot about some of the ones that are getting a lot of attention. I want to share some brief insights into some of those use cases, so that could be interesting to you. And then we will pick a couple of examples, and then I'll walk you through the process of once you pick a right problem to solve, how do you assemble the data. I'll do a very brief use case, and then we'll talk about how to create the predictive model. I'll show a couple of examples there. In the end, based on what we discussed today, I will do a live demo. I'll start with defining a problem and walk you through how to assemble the data live, and finally create a predictive model and use that to drive business actions by showing how to not only predict using your data, and how do you distribute that prediction, and how do you enable your end users to act on it. So my goal is, if I've done a reasonable job with the demo today, the whole presentation today, you will leave with the presentation with good set of ideas to go after, and possibly start figuring out ways to build out a predictive model for your internal use cases. With that said, let's quickly jump on to talk about a typical like a thousand feet understanding of what a predictive process is all about. If you look at most customers out there, most companies, they typically have an application that typically talks about what happened in the past. So what they're all going after is tell me what is going to happen, and then more importantly, tell me what kind of actions I can take, so that if I know what is going to happen, I can take some actions to prevent bad things from happening and making sure good things to happen. That is the key goal for predictive analytics. For example, one common use case that's good to discuss is which we have seen with almost every customers we talk to, is customer churn. They typically report of how many customers churn in the past month or past quarter. Where they are all going with it is tell me who is going to churn, and more importantly, tell me what is the best way to engage with them early to prevent that from churning. That could be a possible use case to go after. If you look at this is an example of a use case where there is a very significant return of investment by solving this use case. So almost every company has many such use cases. So you as a developer just have to figure out, talk to a few people to identify one of those use cases and see what we can do to create a very simple prototype. Having said that, so it is not, it is based on the 300 odd customers we have spoken to. Almost every customer is looking for ways to incorporate predictive insights into the application. So what we are starting to see is many of the application developers in these companies are trying to figure out by taking some data from these business processes and building out some predictive models and showcasing that to their management and to their business users to see if this is something that's going to add significant value to it. That's a key way to become a thought leader in the company. We have seen number of examples that have happened in our customer base where the developers started the project and then that became a very significant initiative in the company. So my goal today is to walk you through the process of picking the problem and then walking through how to formulate a way to get that model to your business sponsors so that your project takes off ground pretty fast. So if we were to think about how do you imagine a typical predictive process to work, the very first thing to do is to figure out what is the predictive problem you are trying to solve. Is it, will this customer churn? Will this user click on the link? Will this customer default on the payment? So pick a problem. Once you pick the problem, the next thing is to assemble the data that has information about that particular problem that could be coming from multiple departments and multiple tables and multiple databases. Once you assemble the data, then you go back and apply algorithm onto that particular historical data so that we can learn why do customers churn, why do people default, so that it is able to predict, it is able to learn from the historical data, and then you can use that predictive model to apply on new data. Let's say a new data is coming through, maybe on a daily basis. You can predict on those new customers and write the predictions whether this customer will churn or not with the appropriate probability into a database or can be done real time. And finally, once you have the results, the next question is, what do I do with it? What kind of who do I need to send this to, and what kind of action can I take? That is a very key part of predictive processes. It's not just important to create the predictive insight. It's extremely important to communicate the insight to your end users and allow them to take action so that you can actually use the insight to drive your business outcomes. And lastly, it's not that once you create a model, you are done. It's an evolving process. So you have to constantly monitor how your predictions are doing. Let's say you predicted these 50 customers would potentially churn, and a month down the road or a quarter down the road, you go back and look at how the predictions are correlating to the actual results. If they are continuing to be good, then you can continue to use the model. If they are not, it essentially means your customer behaviors may have changed over time. So you may have to retrain the model to be in sync with your customer behavior. So having said that, before I jump on to the next part, there's a quick poll to get some audience feedback. I'll give 20 seconds for this poll.
And here are the results from the poll.
Thank you, Billy. So let's move on to the next chapter, next topic, where how do I get started? This is where the biggest stumbling block to move forward for a developer to put in some quick prototype is what is the problem to focus on. So most tend to download data from the internet to play with it to learn, but since they are doing this to enable predictive analytics within their company, it makes sense to identify a data set that's relevant to what your company is doing. So my goal in this section is to give you some ideas to focus on that would enable you to pick a data set that's relevant to your business to create a predictive model that could be valuable to your end users. So the typical way I think about is to pick the problem, get the data, to assemble the data to predict on the problem, and train the model, distribute the results, and finally allow the end users to act upon. That is typically how we think about it. I typically use the word PDA, predict, distribute, and act. That's always the three areas of predict to make your project very successful. Having said that, let's think about how do we pick a problem that is very valuable and that has a good return of investment. The examples I'm going to show you is based on the 300 customers we have spoken to. There are common use cases we have seen that are very popular, that we have seen a lot of traction with our customer base, that would give you some ideas to go after. So there are two ways you can think about the predictive problem. So almost every company has lots of internal data, like from their sales department, from their marketing department, from their customer support, or from their finance department. There are some areas where you can incorporate predictive insights into that, or you can also use customer facing model. For example, if you're in healthcare industry, there are healthcare data we can use to create specific healthcare models. We'll talk about examples of both. Let's start with the internal ones. It's easier to start with the internal one, mainly because yeah, you'll get the access to the data a lot more faster and easier than the customer facing data. The key examples are, for example, in the marketing team, the problems they may be wanting to solve is they may be running lots of campaigns. They may want to know, will this user click on the link? Will this user respond to my campaign? Will this user sign up for this webinar? So everything about responding to a particular event or campaign they are spending money on is a very valuable insight that they would rely on. So that's a good predictive model to get started if we have the marketing data for it. Another interesting one is a customer support, where there are always delays in responding to the customer in most companies because of heavy workload. So what we have seen that resonates with customer support is how many calls will I get tomorrow, and how long is the wait time going to be tomorrow. There's a lot of SLAs to be met. So when customers wanting to predict how many calls am I going to get, or how long would be the wait time, or how long will this call take to complete, or what is the probable time for this case to be closed. Those are all good metrics to measure to predict, and that's going to enable the business sponsor to potentially add additional temporary resources if they see a problem there. So we have seen a lot of customers wanting to do those kinds of internal predictions for customer calls. The next one is finance. The one key one that constantly comes through our customer base is predicting who will pay the invoice late. That's especially very important for customers who are on a subscription based business, where they rely on monthly subscriptions to run their business. So it's very important for them to identify the customers who will potentially not pay the invoice on time. That is the data set you can potentially get from your finance team, and see if we can start predicting something like that. That's going to be of great value to your internal customer. Another thing is how much revenue am I going to get, or how many bills will I be getting, how many invoices am I getting. Those are all good things for the finance team typically gets excited about. And the last one is your customer sales department, where they constantly want to score different deals based on propensity for this sale to close. So that's a very positive thing that they would want to do, which means the ones they believe are high chance of closing, that is where they would prioritize, add more resources to focus on those situations. The other one, we have also seen a lot of demand with our customer. With typically most customers are custom predicting customer churn. What is the propensity for these customers to churn in the coming months or coming weeks? Those are all very important ones to react to. In other words, these are all examples of use cases with a built-in high return of investment, and built-in ways to monitor and monetize on this kind of prediction. So if you're trying to get started on some internal use cases to prove out within your company as a developer to show thought leadership, these are the good examples of some things to get started on. The second set is, so I was thinking I'll pick some examples from different industry. So I picked the 4 industry. We have seen this lot of appetite for machine learning based predictive insights. The first one is healthcare, that is currently leading a lot of predictive deployments. Is so simple things like will this patient get readmitted in the next 30 days, or how many walk-ins am I expecting tomorrow, or will this patient be admitted to the hospital, how long will the stay be, what would be the discharge status. So a lot of will this patient show up for appointment. So lots of interesting use cases you can think of as a healthcare. Some of it are easy to get the data, some of it not easy to get the data. So depending on the company you are working, that's another good way to start with the customer facing use cases. The good thing about the customer facing use cases is you get a lot more funding, you'll get a lot more support from the business sponsor, because by solving the problem, that's going to directly affect the bottom line. The next one, predictive, next one, manufacturing. Again, a very popular use cases we have seen, where customers wanting to predict will this machine fail in the coming weeks, so that I can prioritize the maintenance, or how much is the labor cost, how much is the parts cost, how long the machine will be down. Lot of interesting use cases we could apply for the manufacturing world. Think about it. Every time a machine goes down, the customer would be losing a few $100,000 every hour or so. So these big manufacturing companies make it high importance to predict any downtime in the coming days and coming weeks, and take a priority to schedule to take preventive action to prevent that from happening. Another, if you are a developer in the retail sector, you could think about will this customer buy this product, will this customer return this product after they buy. That we have seen a lot of customers starting to think about. Then other one is cross-sell upsell campaign. What are the products we can sell to these customers? So we have also seen inventory demand, how many orders am I going to get, and how long will it take to ship this product. So a lot of interesting use cases in the retail sector you can prototype, which will affect the bottom line. And the last one, fraudulent transactions, fraudulent claim, fraudulent invoices. Those are all common use cases that we have seen. There is a high revenue attached to it. The common things about fraudulent behavior is the context is very important. For example, $1,000 spent on facials at this location at 11 o'clock this morning is okay, but the same $1,000 spent on facials at the same location at midnight is not okay. So it is not the $1,000 that is important, but the context of the product, the service, the location, the time, all those are very important to predict a typical anomaly. So we have seen a lot of demand there, and also things like payment default, paying invoice late, paying any loans late, and things like that are all good things to focus on. So that'll give you some good ideas for, depending on the industry you are in, that will give you some ideas of use cases you can focus on. That key takeaway from the past two slides is you can start your predictive journey by assembling data from your internal use cases like sales, marketing, or support. Or if depending on the industry you are in, you can also pick a data set from your customer facing use cases and start creating the predictive problems. So once you pick the predictive problem, so the next step to figure out is how do I get the data, how do we assemble the data, and how do I know what data to assemble, right? To answer that question, what I thought I could do is I will take the customer churn example and quickly walk you through like a sample columns that you would have to assemble to be able to primarily understand how to predict if a customer would churn or not. Keep in mind that most times the data could be coming from multiple departments and multiple databases. So it's important that you form something like a committee or a group so who can advise you on these kind of factors. That way, by they being part of the committee, the ability to get access to their data will be a lot easier if you don't involve them in the committee. So from a standpoint of making progress, it's always good to get more people involved so that you get blessing from a lot more people to move on your project. Having said that, if you think about why do customers churn, it could be a lot of factors. Could be depending on what products they buy, how they use the products, and maybe they're experiencing some financial trouble, or maybe they are experiencing some issue with the tech support, or maybe there could be other factors, right? The key is to assemble all the customer touch points, all the factors that could potentially play a role in making customer churn. Could be customer demographics. Maybe they no longer see a need for the example I'm showcasing is a B2C related scenario. Maybe they have grown up and they no longer see a need for it. So using customer demographics is a good way to capture that feedback and information about what kind of products they have currently bought from you guys, from your company, or information about how do they use the product. Is it a heavy usage, low usage, and things like that? And then that's coming from your usage database, and maybe from your financial data system. Are they paying the invoices on time? Have there been any recent defaults? So that you can also capture their financial strength as well. And also the interaction with customer support. This thing is very important, where typically how many calls do they make? Have we seen a lot of calls in the recent past? And has there been any how long since we have heard from the customer? Lot of factors go into figuring out how active we are engaged with the customer. And there are many other factors, like for example, if you're a retail store, how far do they live from your location? How is the weather? A lot of other factors also play into factors. And even life events, like they may make a purchase because their birthday is coming or their family's birthday is coming. A lot of interesting factors go into it. The more information about the customer the more factors you can capture that's able to predict whether a customer would churn or not. What essentially you are trying to assemble is historically data points for what factors are there that contribute to either a customer churning or not churning. So you would have a good amount of data for examples of customers who churned, and you also have a good amount of data samples for customers who have not churned, and that is the data you would pass in to the predictive model to learn, to understand, to predict how would customer churn. So don't wait for everything to align. So you may start with maybe 30 columns or 40 columns, but over time you can add more data to continue to improve the model as an ongoing basis. That's a good way to think about assembling the data by taking multiple factors from multiple departments and putting it in the context of analyzing customer behavior. So once you create a predictive model, so once you assemble the data, the next thing is how do I create the model, and how do I handle? We have seen a number of use cases where they have like anywhere from 50, 70, or even the one we recently dealt with, they had 400 columns. They want to identify the most important columns that have a significant impact on predicting whatever I'm trying to predict. So I'll walk you through how do you deal with those scenarios, how do you create the model, and how do you distribute the information and take some actions. The first one is, let's talk about building the model. So for this, the example I want to use is a healthcare example. The one we recently did is predicting a risk score for a chronic condition. For example, you could have historically data for samples of data for customers with that condition, samples of data of a customer without the condition, so that they can learn what makes somebody develop the chronic condition. That way you can predict in the future patients who are risk of high risk for the particular chronic condition, so that you can take preventive action. Lately, the focus for healthcare has been prevention, then solving a problem. So we are able to prevent something from happening, you don't have to worry about solving the problem, right? So we have seen a lot of emphasis on predicting a risk for various chronic conditions and taking alternate treatments like changing socio-demographic factors, working out, therapy, yoga, and things like that to prevent any onset of those chronic conditions. So having said that, so once you create the predictor, once you assemble the data, the key thing is to identify what factors are most predictive in nature with respect to predicting the risk of specific chronic conditions. Maybe out of your 40 columns, maybe 10 or 12 of them, the top 10 could be the columns you can focus on. The interesting part about picking the top columns is, yeah, you will see from the demo where the columns you are picking to create the predictive models. If you're able to take the same columns and show that in the dashboard, all those metrics, and communicate to the end users, it makes it believable, and it makes it easy for your end users to be able to understand what is going on. And lastly, once you're able to create a very good predictive model, you can start thinking about how do I deploy this model to your end customer. For example, once you create the predictive insight, you may be wanting to predict on a daily basis, maybe every day at 7 p.m. my data is coming through. I would create the predictions and then deploy it. That's a demand process. Or when the patient makes a phone call to my call center, that is when I may potentially create that prediction. So end result is you're able to communicate that to a very simple application to your end users for them to understand what is going on, which patients are high risk, and what kind of things I should be doing to take preventive actions. And not only you are predicting what is going to happen, you are actually communicating the information to the end users for them to understand what is going on. More importantly, enable them to by enabling actions within the context of the application for them to take some actions to prevent things from happening to the end customers. Lastly, it's not important just to create the model. It's very important to constantly monitor them and take some and constantly improve them. For example, let's say your accuracy is 80% and you are predicting, and maybe your customer behavior is changing because you are running some campaigns and things like that. Maybe your accuracy has gone down. That essentially means that the customer behavior you have modeled in the model has slightly changed. Essentially, you take back the new data and feed it back into the model and let the model relearn. In other words, over time, the model is constantly tweaking itself and learning what is happening to your data so that it becomes intelligent over a period of time. So maybe the first version of the model may be lower accuracy, but over time, as new data comes in, it gets better and better and better and becomes easy for the model to predict. With that said, I'm going to jump on to a very quick demo to illustrate how do we walk through this process to a live scenario. The example I'm going to showcase is as predicting machine failures. So this is a scenario that we worked on a few weeks ago. So we had more than 40 columns. Just to illustrate the problem, I've just captured a small set of columns to illustrate how to solve a problem like that, starting from creating the predictive model all the way to distributing it and taking some action. So if you are a customer, if you are a developer working in a manufacturing company, so you can start thinking about how to create the problem. This will give you a good example. I'll start with creating a predictive model by picking, in this case, I'm picking whether with this machine fail or not. That will be what we call a classification model. And then I'm going to go pick my data set. I'm going to this data set has samples of machine that have failed and samples of machine that have not failed, so that I can feed the data to the algorithm. So in this case, I have machine type, what kind of problem it is, and how long since it has been maintained, and how old is the machine, and has there been any problem recently, and how often the machines are being used, and then information about the machines, and then whether they have failed in the recent past or not. I'm going to remove the ID and the repair time. So I'm going to, in this case, I've only taken a small subset of the data, but in most customer situations, you typically see more than 40-50 columns. The first thing I may want to do is which columns are extremely relevant in predicting whether a machine is going to go down or not. So typically this includes sensor values, which I did not include in the data set. It tells me that how old is the machine and how long since it has been maintained are the top 2 factors. And typically you can pick the top 5 or top 10 factors. If you have like 100 columns, you can potentially pick the top 5 or top 10 columns to experiment your model. And then you can start training the process to create a very simple predictive model. And one cool thing with this products like Logi Predict, if you have any data problem, it will automatically fix those problems like missing rows, missing values, incorrect data types, and things like that, so that it can predict with a reasonable accuracy whether this machine which fail or not. So I've done that, get a very simple predictive model. Now I'm going to deploy it to predict on new machines. Let's say I have around 300 machines currently running. I want to be able to take this model I've just predicted, apply it to those machines. So these are the machines where I do not know how many of them will potentially fail in the coming weeks. That is what my goal for the prediction is. I want to predict this and write this to a database called results underscore machine failure. On the column, I'm going to write the prediction is called failure predicted. And then since I might do this every day, I want to add the timestamp to it. So what it is doing now is for those 300 machines, it's applying the predictive model to predict will this machine fail or not in the coming weeks, and those predictions are returned to a database along with the probability. For example, the first two machines will not fail, the next two will potentially fail with the probability of 70%. So which means what we have seen customers do is all machines with more than 85% probability it will fail, they automatically schedule maintenance in the coming days. Less than 85%, they do it 1 week down the road. So you can take significant action based on this insight. The next question is, I've created a predictive model. I've predicted that on new data. My last part is how do I use the information? How do I enable my end users to act upon it? That is my last part of the demo. This is a very important part to succeed. So those machines, those out of 300 machines, I've put a very simple dashboard that tells me that 60 of them will potentially fail in the coming weeks, and then good number of them are mechanical problems. We have seen that milling machines typically have high probability of failure, and a good number of the machines have not been maintained in the last 2 months, which means we got to prioritize maintenance. And many of these machines are having problems which have been pretty old machines, and interestingly their usage have been pretty high. So I think the model did a pretty good job of predicting some of these stats, and then you can actually take pretty good actions here. For example, this machine has a 74% probability that it's going to fail in the coming week, and it has 615 pending orders currently. Well, the action I could take is I can schedule ask support team to schedule for predictive maintenance, and I can also reschedule the orders to a different machine, so that when the machine is down, the orders that have come through can continue to go after, right? And then if you look at the machines like this, where as a 96% of the probability that this will not fail, maybe these are all the machines where I can move the orders. In other words, not only am I predicting which machines are failing, I'm also recommending another model that is recommending what is the best action to take, so that one model could be predicting which machines are going to fail. Another model could be predicting what is the best action to take. In that process, you as a customer can not only you can have multiple models all talking to each other, so that your entire enterprise can be run in a very intelligent way. That is where we are starting to see many customers deploy multiple models. Having said that, I'll quickly summarize and then we can stop for questions. I think we are close to the 40-minute mark. In summary, the way I would think about starting a predictive journey is we talked about number of internal and use cases and external use cases. Pick a problem that you believe has a good predictive and a good return of investment. Take that and work with your team to assemble the data. That's a very important part of the problem. And then use you don't need to know the R or Python to create those models. If you use tools like Logi Predict, there's a lot of automated algorithms to create those models and also do automated data prep. You can use those to build out a very good prototypes. And more importantly, it's very important to think about what kind of how do you distribute the predictive insight and what kind of actions you can take, so that when you go to a business user, you can talk in the language they can talk. You can show them hey, this is the problem it's predicting, this is what the how we can communicate the information to your audience, and more importantly, show them what action we can take based on the outcome that we have predicted. That's going to make your business sponsor get pretty excited. And the key is time to market. What we have seen is putting a prototype, getting it in front of the customer, your end users, your business sponsors, and get their feedback. Iterating on that is a very important part of the puzzle. And then after a few iterations, you will get to the right set of metrics to go after, and that's going to make your life easier. That's going to make your project successful. With that said, I'm going to pause here for any questions. Are there any?
Thank you so much, Sriram. We do have a few questions that have come in. The first question is, how often should I retain the model?
Typically, we have seen typically a 1 month or every quarter is what we have seen most customer retrain. That is based on comparing your predictions with your actual results. If they are matching pretty well, then once a month or once a quarter is good. But if you see a discrepancy, that is when you may retrain the model often.
Awesome. The next question that we have is, can I do real-time predictions?
That's another good question. Yes, like we have seen customers where when a customer makes a phone call to a bank call center, that is when they want to predict if this customer would default or not. So product Logi Predict, we support real-time predict APIs using which you can take real-time predictions.
Great. We do have another question. Next question is, do you have any guidance on how long it takes to build out a predictive application end to end?
That's another good question. So based on different customers we have worked with, the entire process typically takes anywhere from 2 to 6 months, because once you build out the predictive model and building out the appropriate visual elements and different actions they would take, and then reiterate that by doing a beta with your customers and addressing the customer feedback, and testing them to make sure all the numbers work out. Typically, it's anywhere from 2 to 6 months is what we have seen traditionally customers take to deploy to take it live.
Great. The next question that we have is, what is the accuracy with the predictive models that you've worked with?
That's another good question. It depends on what kind of problem you are solving. In a typical marketing problem, we have seen most customers even start with 55% accuracy, because most customers currently do predictions, do those kind of predictions based on gut feeling. Most gut feeling is like 30% accuracy. If they see a model that has 55% accuracy, they get excited. Beyond 60 to 65% is when they start thinking about going live for marketing related use cases. And over time, maybe version 1 will have 70%, version 2 will have 75% accuracy. Over time, they improve the model. But in other scenarios like healthcare and things like that, they demand a higher accuracy because of what is involved in that process. So depending on the use case, the accuracy may vary from 60% all the way to 90%.
Awesome. The next question is, can I bring in external data sources?
Yes, that is actually a second iteration of what most customers do. maybe the first iteration they may just deploy with the whatever data they have, and maybe the second iteration, for example, if they have zip code, they may go back and bring in census data for the population in the zip code, the average income in the zip code. In one of the recent healthcare customer we worked with, they wanted to also bring in how many gyms or how many parks that are there in the zip code to capture the metric that healthy people, typically more healthy people live in this particular zip code. People also starting to bring in social media data as well. Those are all good things to bring into the system as a second or third iteration of your model.
Awesome. The next question that we have is, how do you identify what is the best action to take?
Yeah, I think initially you may not. Initially, you go with talk to your the field operators to see what action they currently take. Pick couple of them, and that is what you put that in the application. And then over time, maybe 3 months, after 3 months, you monitor which actions are working, which actions are not working. Then once you know which actions are working and not working, you feed the data to create a brand new predictive model, so that the first model can predict who will potentially churn. The second model can predict what is the best action to take to prevent that from happening. That is how you create a best action model from the data you collect.
Awesome. We do have one more question. So audience, if you do have any more questions, please post them into the questions panel. The last question that we currently have is, for the demo you gave, do you refine the model based on machines without a maintenance intervention, or can you use the machines with maintenance interventions as well?
That's a great question. We can model it. We can use for both. We could even include another column. That column could have those two different options as part of the training process. So we can capture that particular parameter as part of the model. So we have seen typically customers create some customers create one model that captures both the maintenance related data as well as live sensor data. But we have also seen customers where they have two different models, one based on maintenance data, one based on sensor data, and then they take the average prediction called the ensemble prediction. And I think that both are good ways to go after.
Awesome. Well, Sriram, that does look like that is all the questions that we have. Would you like to add anything before I close things out?
I think that is great. I think hopefully everyone got a good sense of how to pick a problem and how to proceed by assembling the data and create the predictive model. And if you guys like to discuss or see how we can build out a predictive model using the tool I just showed you, feel free to connect with us and with the poll, and then we can definitely work with you to build or help you build a predictive model for your own custom data.
Great. And with that, I would like to thank you, Sriram, for a great presentation. I would also like to thank today's sponsor, Logi Analytics, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.